What is low pass and high pass filter? Required components for practical session. See this below components for practical session. Types of wave shaping network. Wave shaping circuits consists of two types. One for linear wave shaping net circuit. Another one is a non-linear wave shaping circuits. So here the linear wave shaping circuit has a three types. One for RC circuit, another one RL circuit, and third one is the RLC circuit. Here the non-linear wave shaping circuit has a two types. One for clipper, another one is a clamper. Clipper also we had some session previously, so we know that the clipper how it is work. Then clamper, the next session I will explain the clamper related details. Then here the RC low pass filter or RC integrator. The RC low pass filter circuit consists of resistor and a capacitor network. Here resistor is seriously connected, capacitor is parallelly connected. We use here 1K resistor and also capacitor value is 0.22 microfarad. Now here when we apply the square wave from function generator, the square wave is converted to the same square wave when we apply the low frequency value. Otherwise, the waveform is changed when we apply the high frequency. Like here, the shifted triangle waveform is present, and input side we increase the more the frequency range, like 1 kilohertz to 1 megahertz frequency range is increased. The output side is present the exact triangle waveform. This waveform, all waveform is considered for this RC network using this formula. This formula base that waveform output is present, like a frequency, the capacitor value, then resistor value. That is the important parameters in this circuit. Here time constant RC equal to 1 by 2 pi FC. So frequency we know and capacitor value we know. So we easily find out this time constant and also the capacity reactance. Then cutoff frequency also here it is mentioned. Cutoff frequency and phase shift equal to FC equal to 1 by 2 pi RC. So we know the RC value. So here it is we use then we found this answer. And then VOT equal to next one is a VOT equal to V in and multiple XC divided by root of R square plus X square. Then they easily found this one also because of the all value we know easily found. So gain and number of stage number n is number of stage. We use this formula 1 divided by root 2 and whole power of n. This is the gain and n is number of stage and also overall gain in dB equal to 20 log of V out by Vn. This is a RC low pass filter. Here this resistor is series, capacitor is parallel. Next we will see this RC high pass filter. This is a RC high pass filter or RC differentiator. Here look at here the previous circuit, the resistor is series, capacitor is parallel. That is for RC low pass. From in this circuit, resistor is parallel, capacitor is series. So in this case, we apply the input square waveform from function generator. That waveform is converted in this spike waveform because of we apply the high frequency. Okay. So First we apply the lower level frequency, we get this spike waveform. Medium level, also the spike waveform. When I go for this high frequency, the same frequency is present output when I apply the very high frequency. So here square wave is apply, the output side is present the same square wave, but some distortion in this waveform. So the frequency is more frequency is apply, so that output is present correct form. This is the RC high pass filter, only allows the high frequency, not for this low frequency. But here it is also same. The square wave only allowed the low frequency, not for high frequency. That is a vice versa. Low pass filter to high pass filter. And here the cutoff frequency and phase shift formula, we use the same formula Fc equal to 1 by 2 pi Fc, and phase shift pi equal to arctan and 1 by 2 pi FRC, and gain also is the same, AV equal to VR by Vn equal to this formula we can use in this high pass filter, R divided by root of R square plus X square equal to R by Z. And then yeah, that is the main formula we use in this RC differentiator or RC high pass filter. Let's see practical session.
Hello all. Here this is a circuit. This is a circuit for a high pass filter or RC differentiator. This is a function generator input. This is a function generator. I fixed the 35 Hz frequency, and also here the input CRO input. This is a yellow highlighted line is the input of the CRO, and then this is the output of the CRO. That is, we using two channel. This is a channel 2, this is a channel 1. And channel 1 is the input, channel 2 is the output. Now the circuit has a one capacitor, one resistor. I'm using a 0.22 capacitor, microfarad capacitor for high pass filter section. Here the capacitor is seriously connected and resistor is parallelly connected. This is a high pass filter. Now the low frequency, see this output, the waveform is collapsed. Yeah, this is not the correct waveform, square waveform, because of here we use a very less frequency. So high pass filter, the passing on the high frequency, then avoid the low frequency. Now I increase the frequency range. Now frequency range is 1 megahertz. So now you see this waveform of this square wave. Now the square wave is, whatever the input is be given, the same output is present, because of the circuit only consists for high frequency. So now the only that deliver this high frequency in this high pass filter and suppress the low frequency. Whenever we apply the low frequency signal in this function generator, that time the waveform is collapsed. Then when I go for this high frequency range, the output is present very clearly, not collapse any the waveform shape. The exact shape is produced. This is called high pass filter. And next one is the low pass filter. See this is the circuit as a low pass filter. Here the resistor is seriously connected and capacitor is parallelly connected. This is the input frequency. This is the input of this CRO. This is the output of the CRO. Now see this, the frequency range in the function generator 1 megahertz. So the output is, see the output of the CRO. This is a no waveform is produced, because of this is a low pass filter, not allow the high frequency. See this output of this waveform. So now this is the low pass filter. Here I apply the square waveform and output side present this triangle waveform. Now I apply the 56 Hz frequency. This only passing the high low frequency signal. So whenever the high frequency is applied, the signal is going to straight line, DC line, because of not deliver this high frequency. Yeah, we are connected in low pass filter. Thank you all. Subscribe on my channel and also share my video to all. Thank you.